Hey folks, and welcome again to Advent of Code in F Sharp, day 14. You might have noticed that a couple of days have been a bit quiet on the streaming front, but it's super busy at work, so yeah, I'm keeping up with the puzzles as best as I can, but I don't have the time to keep streaming. I might come back to them later because there were actually some really interesting things in the last couple of days. But without further ado, let's take a look at day 14. Regolith Reservoir. The distress signal leads us to a giant waterfall. Actually, hang on, the signal seems like it's coming from the waterfall itself, and that doesn't make any sense. However, you do notice a little path that leads behind the waterfall. Correction. Yep. Sand begins pouring into the cave. If you don't quickly figure out where the sand is going, you could quickly become trapped. Our familiarity with analyzing the path of falling material will come in handy here. Yes, this is ringing a bell. Was it the water? Yeah, it was the water thing from 2018. Oh my god, has it been 4 years already? This is a very cool yearly tradition. Anyway, so we are doing something like the water overflowing thing. Cool. We scan a two-dimensional vertical slice of the cave above you, which is our input, and discover that it is mostly air with structures made of rock. So we have again 2D thing with air and rock. Cool. Our scan traces the path of each solid rock structure and reports the XY coordinates that form the shape of the path, where X represents the distance to the right and Y represents the distance down. That is my usual XY layout. Cool. Each path appears as a single line of text in your scan. Let me reread that. So we have a path of each solid rock structure, and that's an XY coordinate, multiple XY coordinates that form the path. Okay. And each path is a single line of text. Cool. Okay, so we have straight, horizontal, or vertical lines, no diagonal shenanigans for the paths. Okay, and that's just, okay, it's starting to make sense. Interesting twist, okay. This scans means that there are two paths, because two lines, yes, first path consists of two lines, from this to that, from that to that, makes sense. Makes sense. We have an entry point for the sand, which is 500, 0, cool. Rocks are these hashtags, dots are air, makes sense, and sand starts flowing from over there, cool. Sand is produced 1 unit at a time, and the next unit of sand is not produced until the previous unit comes to rest. Oh, we're building a different physics engine, right, cool. A unit of sand is large enough to fill 1 tile of air, makes sense. It always falls down 1 step if possible, cool. If immediately below is blocked, the unit of sand attempts to move. Oh no, it's moving diagonally. 1 step down and to the left. So we have a left bias. If that tile is blocked, we go 1 step down and to the right. Cool. Sand keeps moving as long as it's able to do so at each step, trying to move down, then down left and down right. If all 3 destinations are blocked, the unit comes to rest and no longer moves, at which point the next unit of sand is created back at the source. That's some very intelligent or a hive mind sand. The next grain of sand knows when the previous one has come to rest. Cool. Okay, that makes sense. That makes sand. Oh god, it's 6 o'clock in the morning, forgive me. Okay, makes sense. So when we have a grain of sand that has come to rest because it cannot go down left or right, and then the next one is generated and the process appears. And grains of sand also block each other probably. Yes, they do. So we are building mountains of sand. Interesting. All for the sand flows out the bottom, falling into the endless void. Okay, yeah. Okay, makes sense. We have an endless void. Using your scan, simulate the falling sand. How many units of sand come to rest before sand starts flowing into the abyss below? So this is the example and it should be 24. How will we detect when we're done? Instead of just going one by one or one cycle per cycle, I think we can work grain of sand per grain of sand. And if we notice that there's no fixed point for a grain of sand, so that it just keeps going down, how do we detect it? Maybe we can find our maximum y coordinate, and once we move past that, we're done. Is it a good idea to straightforward or to just simulate this whole thing? How big of a problem space are we talking here? Somewhat big-ish, but not huge. Is it too soon to start thinking about optimizations? Yes, it is too soon to start thinking about optimizations. Let's start with the brute force simulation approach. We have 148 rock paths, and they're pretty big-ish. Okay. Let's grab the example as well. Let's start on something smaller. Oh yeah, it's just the 2 paths. That will be more straightforward to take a look at. What's the best data structure for these kinds of things? Sand will be moving around or will be falling down, but I think instead of discretely modeling the grain of sand falling down 1 unit at a time, I think we could maybe figure out where it's going to end up in one fell sweep. Because it's just down or diagonal left, right. For that we need to know all rocks or existing grains of sand in a column. So we need fast access to all elements in a column or in a range of the column. Starting to sound like an array 2D again. How performant is an array 2D regarding updates? I have no idea actually. I don't know how it's implemented. Do we have an idea of the complexity or the performance characteristics? What happens if you update an element in an array 2D, or if you create a new one, perform a shallow copy? Not sure. What are alternatives? Lookup tables, maps, but it's a bit of a pain to figure out all elements in a column. That's not the most performant operation you can do on a hash map. Maybe it's not that bad if we group columns, if we have a lookup table that just returns everything in a column, a 2-dimensional or a nested hash map. That's maybe already a performance increase that we don't need, but let's try it out. I've never used them to a nested map to do stuff like this. Let's try it out. So I have just convinced myself that our what is it called? A cave? Yeah, a cave. So what does our cave look like? A map of what to what? A map of... Is column okay? Actually, no, column is not just okay. We need to go diagonal as well. Let's keep it simple. I'm just gonna use a lookup table or a map to get started. So no performance optimizations yet. So we map a location. Let's just do that with a tuple, and it maps tuples to an element in the cave, and an element can be air, so nothing, rock, and sand at rest. Let's not model the sand falling down. Let's call it a thing. It's very domain driven. That's ubiquitous language right there, a thing. So that's either air or rock or is it a good idea to explicitly model air as a thing, or should the lack of a thing imply air? Let's not model air because it's an infinite space and we would like to not have random things in our cave. If there's like air below, it's gonna be harder to figure out where the bottom of our cave is. I think. I'm not sure. I have not convinced myself fully of that statement. But let's say we'll start with this. Let's parse our input and let's make these paths into actual rocks in our cave. Yes, let's do that. What do we need for that? We need to parse our paths into lists of tuples. And from that we can generate every point along the path, I think so. They are always orthogonally adjacent, or not adjacent, but the x or y coordinate is always, they always share one of those. Yes, yes, okay, let's try it. Let's write a parse line. Let's grab an example and let's write a parse line. I would like all chunks. Yeah, and now we can parse all coordinates. Should give us, yeah, and now we can parse integers from those things. Yes, and if we just build tuples out of these things, I think we have our locations, or beginning and end locations. I'm doing too much in one go. What's happening here? Too many parentheses. Not enough parentheses, that's even crazier. Sorry, why is this not working? Let's roll back a bit. If steps get too big, let's rewind a bit and let's see what's happening. So we have this. These are our pairs of integers. Yes. I'm just gonna pipe again and see whether this works. What's happening? Why is it saying I don't know what I'm doing? It's because I don't know what I'm doing. You know what? These are the coordinates in raw string form. These are the XY values in raw string form. Let's write a parse coordinate thing. So we're extracting a bit of the function here. So this is something I call chord. And if we split it, and if we parse it, we can now actually extract it instead of typing it again. Sure. Of course, it's an array, and I was mapping over it. So yeah, that made no sense what I was trying to do. So let's call this oh, you know what? Let's just call this my naming skills are not have not fully awakened yet, so we're gonna have to deal with some bad names just for now. I think we can now parse XY coordinates. Yes, we can. So forget I ever tried anything. So these are the coordinates. Let's do a parse coordinate on them. And there we go. We have our coordinates for our paths. Now let's generate all the points along this path. Sounds like a pairwise. So these are the corners. These are the corners, yeah. I'm gonna make a list out of it. No need to be lazy, or no need to have a lazy list. We can work with, yeah, we can work with just the lists. Yeah, so let's grab these pairwise now. And let's collect our flat map. Yes. And generate points online. And it's a line, not an online. There we go. This function will just generate all points on a given line. Pairwise returns tuples, yes. x1, y1, x2, y2, and that generates a list. And this thing, wow, what's happening? Why is it saying WAP? Okay. Because types. Cool. How do we generate all points on the line? I think if we just do a for comprehension, because we know they're not diagonal, those points, I think we can just get away with it. So let's see. Maybe we need to know, can you do a for comprehension in this kind of direction? From a higher number to a lower number? No, you cannot. Then you need to do stuff like this, right? Yeah. Let's find the smallest one and the biggest one. So if we sort x1, x2, and if we do the same for the y's, we can start generating, I hope. So now for x in, x min, x max, do stuff. And what we want to do is, do we need to have a nested list? No, so we can just do this and yield me the xy tuples. And syntax highlighting is telling me I made a mistake somewhere. I did. So incomplete matches, we know. No worries. This does not appear to be correct, right? Let's take a look at this. So we should go 4, 9, 8, 4, 5, 6. And then we should go 4, 9, 8, 6, 7, 8, yeah. The only problem is we're generating duplicates, which is true. I'm not gonna bother trying to fix that. I'm just gonna distinct them. That's just for one line. We can even, yeah, lines will not cross. That's good enough. So does this make sense what we're seeing? It makes sense what I'm seeing here. So it should be 1, 2, 3, 4, 5 for the first line. Is that what we're seeing? That's a 498 thing, 496 thing. That's this thing. Yeah? 1, 2, 3, 4, 5. Yeah, and the other one should be way longer. But I'm gonna trust the process. We'll see. Figure out when we have made a bug or when we have introduced a bug. So these are all the coordinates. What's the next step? Putting those in our cave. Putting those in our cave. These are all the coordinates of all the given paths. Yep, looks legit. And we should dump those in a map. So let's grab path coordinates. And let's collect those. They can be flattened. And if we now map that thing to a coordinate and a rock, we could feed it into a map, right? No? Is there no map constructor? There it is. So yeah, this is our cave, I think. That was a 20-minute stint parsing our paths, but we have our paths. It's a pretty basic, no frills implementation, 0 performance considerations. Let's see how far it gets us. We have our cave. What's next? We need to be able to drop a grain of sand, right? Was it 500 0? It was 500 0. So that's where grains of sand originate, and they just fall down until they hit something. And when they hit something, they try to go down left, down right, and if that's not possible, that's where it stops. So what do we need to figure out? We need to figure out the first thing it's going to hit, or the location of the first thing it's going to hit. Yes, and yeah. I made a choice to go with a map. Let's stick with it just a while longer. So, let's first hit. How are we going to figure this out? So it's taking everything in our cave with the x coordinate of 500, sorting that on the y coordinate, and the top thing is whatever it is. So everything on the y-axis in the cave. Yeah, finding entire columns is not what map was made for. But okay, what does filter work on? On the key or on the value? On both, cool. That's the coordinate, we don't need it. That's the thing. We do need the coordinate, sorry. X, we don't care about Y, and we don't care about thing. Is there something on 500 in our cave? This should be right. This should be in the example. There is one thing on the cave, something on the y coordinate 9. Yes, there's something on y coordinate 9. So these are all the things we have on our line 500 or column 500, sorry. And then we just need to grab the topmost thing. Yes. Ooh, this sand falling is going to be recursive. Yes, it is. Interesting. But that's not new. It makes no sense to sort a map. No, it does not. So let's drop to list. Sort by what? Sort by... What should come first when we're sorting? The y coordinates, yeah. What do we have here? What is x? It's a tuple of locations and things. Okay. So it's a tuple of locations and things, and we need to sort on the y coordinate, right? And it's descending, I'm guessing. So that grabs, sorts all the things in this column, and then we should grab the first thing, right? Let's grab the head of this list. On y is not the correct thing anymore, so let's call this on y, and let's call this first thing is everything on y. So the first thing we hit is this thing. So if we hit something, we need to try again. We need to try again, right? We need to try again by if the tile is immediately below if the tile immediately below is blocked, the unit of sand attempts to instead move diagonally one step down and to the left. I'm thinking, did we make the smart move by having the sand go from 0 to 8 in one fell swoop? Yeah. Yeah, sure. Sure. Okay, so if we hit something, we still need to try falling down further to our bottom left. So this is the end point, unless we can fall to the bottom left or bottom right. So let's take a look at what's in the bottom left. No, that's not true. Yes, that is true. Yes, that is true. We just have to look at what's down there. So what is down there? And where do we need to take a look? What is bottom left? That's x minus 1. That's x minus 1, right? Of this thing. I'm just gonna destructure it here to have this name out there, first thing. Bottom left is x minus 1, but y plus 1. So we're taking one step down, one step to the left. Yeah. So if if the cave or the slot at the bottom left is free, then we should do the same thing recursively, but have the sand drop from this location, right? Yes. So let's drop sand. Let's create a function. And it drops things from a location. Let's call that start X and start Y, and this thing is the start X. So now I'm reworking my thing into a recursive thing. Start Y we don't need right now, but we are going to need it. So if bottom left is free, then drop sand in exactly the same cave, but not from the 500 0 thing, but from the bottom left thing. So that's this. Just extracted a function. Why is it complaining over there and not over here? Because I need spaces? No. Huh? What's going on? Is it because I'm doing stuff like this? Yes, it's because I'm doing stuff like this. I'm sorry, I'm getting confused here, so let's quickly return unit so we have a return value. What's going on here? Cave is a map, that is correct. So this is a list, yes. And this should be a single thing. Yes. Ah, there's a problem. Yeah. That's the location of the first thing, and that is the first thing. So I am going to destructure this a bit further. So we got rid of the name. Okay, we'll reintroduce it once this compiles. And let's introduce the method is free, so that at least starts compiling. So then drop sand cave in the bottom left. So we're gonna try that. Otherwise, bottom right, we're going to do the same thing. What is bottom right? That's to the right of us and downward, so that's this thing. Yes, I'm just gonna put it here to keep things symmetrical. So if the bottom right is free, we do the same thing. Bottom right, then drop the sand, but our sand is teleported to the bottom right, and otherwise we cannot go further. We hit something, diagonal left is not working, diagonal right is not working, so we are at rest. This means we need to drop our sand right at this location, right at this XY. No, one higher. Ooh. One higher, of course. Oh no. I'm off by one. So this is not the location of the sand, right? No, this is not the location of the sand. This is the thing, the existing thing. So my XY is same Y. No, same X. Same X. One Y smaller. That's where my sand is at. Yes, that's where my sand is at. So, if nothing happens, we can't fall down any longer. We are going to update our cave with sand at this location. And what's here? There is sand at rest. And let's write an update function. those are the 2 building blocks we need to do, and then I think we might be off to a good start. Can it be that we're not taking a look at start Y? It can... Oh no, that cannot be. I started this thing, yeah, this thing, on Y, but it can be that sand drops, goes diagonally, and it can be that there's a path or a rock above us and we don't care if we got there like through a sideways motion. So no, we actually do need to do something with this. So we need to be in the same column, but we only need to take a look at things that are below us, not above us. So we do need to take a look at the Y here. And the Y of the things should be larger than where our sand is. Because larger means lower, right? Yes, let's say I convinced myself. Ooh, this is territory for off by ones. Why am I not testing this? I've been saying this for 14 days now, and I'm still not doing it. Will I ever learn? But anyway, let's take it one step at a time. And pretend that testing is not a thing. But anyway, let's first do the update, because that's the easy part. Let's drop origin down a bit, because we are going to need it once we're starting to write our main loop. Update. What does an update look like? It's a simple map.update or add, but I like to keep my data types abstract, so my whole thing in the code does not depend too much on the data structures. And as I'm saying this, I'm noticing that I actually kind of depend on it being a map right here. So yeah, I've seen that. So this was not the most useful abstraction, but here we go. It's there. So that should compile. That works. Yes. How do we know whether a location at the cave is free? What's in our cave? Rocks or sand at rest. If there's nothing in the map, it is empty void. It is the abyss. I'm gonna type my cave explicitly because I see that it's not being used anywhere, and it would be nice if we start working on our data types. I'm sorry, getting distracted yet again. So let's look up what is in there. So it can be that there's nothing in the map, so let's do a thing add, and let's write a thing add. And let's try find. So if we have nothing, that means it's void, so it is free. If we have something, and it can be rocks or sand at rest, we don't care. That's not free. That's occupied. There we go. That was what, 15 minutes of programming without feedback. It's all the things I tell my teams not to do. So funny, or not so funny, but do as I say, don't as I, not as I do. That's the worst advice I've ever given someone. Anyway, getting distracted. Let's grab our cave here. We have our cave here. And let's drop one grain of sand from the origin and see how far that goes. So drop sand in our cave from origin. Give us something. Do I have a thing at? Yeah, I have a thing at. Where do we expect our... You know what? No, I'm just gonna list the whole cave and see what we have. We have sand at rest. That's good. At 508. At 508. Ooh, that appears to be correct. That's awesome. So that's our first grain of sand down. Let's see whether our second grain of sand goes to the left of it. So that should land on 499.8, right? Is that 499.8? Yes. So we have how do we pipe this? So that's a cave. So if we flip the arguments of drop sand, so cave is the last argument. That makes more sense, yeah. So I'm flipping arguments here to make it compose or to make the pipe operator work a bit better. Should still do the same thing. You just moved stuff around. Let's see if that is the case. No. Okay. What? Oh yeah. We have to move stuff around here as well. Yeah, that still does something. Let's see if we still have our sand addressed. We do. Okay, cool. So now we can start using the pipe operator a bit more. So if we drop sand at origin, we have something. But let's say we do that again. Interesting. Why am I only seeing a single sand addressed? So this is correct, but then we should expect a second drop of sand at rest once we do that again. And it is not. Interesting. Where's the bug in our thinking? Are we using the correct cave? Yes, because I only declare cave down here. I only pipe it in just the once. Let's print out the cave just to get our paranoia out of the way. Because I'm not seeing the problem. I'm not really seeing it right now. Let's maybe clear the rebel so we can see what's going on. There we go. What's happening? Why are you not happy? Yeah, we should be printing the cave in full for this example, or this small example. It's doable, so let's do it. And let's try that one more time. We have a cave with no sand at rest. That is true. Then we drop. Or we start from a cave with sand at rest. So yeah, that looks correct. So there's a problem in our logic. Okay, so first iteration works just fine. Second iteration says no. Instead of debugging, I'm just gonna do print fn driven debugging. Because why not? And let's put one more in there. And let's take a look at what's happening. Okay, so we have, let's extract this. So this is dropping 1 grain of sand, and now let's drop another grain of sand on top of that one. So we can debug somewhat more sanely. What's happening? We have sand at rest over here, yes. And then we say, hey, we found sand at rest. That is correct. Oh, our order by our thing we're taking a look at, or thing, should not be descending, it should be ascending. We should take the highest thing, yeah. Bug, that's at least one bug. And yes, a test would have caught that way sooner. So, is it better now? Ooh, it's better now. Cool. Okay, cool. I think we might have spotted at least one bug and took it out of there. So this looks better. Yes, this looks better. How many times do we do this in the example? A lot of times. What would our algorithm do right now if we find nothing? So what happens if we fall into the void? Then our on Y becomes empty. So I'm expecting it to crash on list head if we keep doing this without a base case for our recursive thing. So let's verify. Let's do this indefinitely until we see it crash on list head. And it should happen after 24 iterations. So if we just let it crash and we keep track of the number of calls, we should end up at 24. Let's give it a try. So let's write an infinite loop here that just takes a cave, and every time it drops sand at origin, and that's the next state of the cave, and we go again. So this should crash pretty hard. Ooh, it does. It's even crashing on head. So we called our shots correctly. That is what is happening. I think if we now print out the iteration, there we go. Let's print out iteration. We should see 24, right? And then we can clean up and have it not crash, but it's a good first attempt. 25 off by 1. I'm willing to count this correct. Can we explain why? Let's say, hey, we're gonna try once. Yes. Yes, I think this is correct. So, what's the problem, or the remaining problem? This thing can be empty. We can fall into the abyss. What should we do once we fall into the abyss? What is the return type of drop sand? A cave, right? Should we just have it no op? So if we have nothing, we say, okay, here's your original cave again. Yeah, let's do that. So if on Y is empty, then we're done. And otherwise we go for another round of sand falling. There we go. So now we have a base case. Or it's not a base case. We're not falling into an infinite recursive loop here. We're just crashing on list.head of an empty list. But this works, but it would keep dropping sand and the sand would keep falling into the abyss. So we need a halting condition in our loop here. And I think I'm just gonna do fixed point. I'm just gonna do fixed point. Fixed point is a recursive kind of a way of doing things where you just do something, and you compare subsequent iterations. And if nothing has changed, you reach the fixed point, so you know, okay, we're done here. So I'm just going to do the same thing. So we're gonna have next is cave, and if next and cave are the same, so nothing has changed, so that means one of the abyss things happened, we're done. And otherwise we are going to recurse. And that returns a cave now. And let's keep the iterations in there. Sure, let's keep the iterations in there. So we are done. And what do we need to count? The iterations is the same as the grains of sand in our example. Yes, that is true. Let's not keep track of the iterations. No, we can keep it in. It's not gonna hurt anyone. So we just need to count the iterations or the number of grains of sand at rest in our cave. You know what? Let's return our iteration as well. So it returns a tuple of the iteration and the cave. Brilliant. Is it still making sense that it's 25 instead of 24? Yes, after 50 minutes of puzzling and a whole day of work ahead of me, it makes sense enough. So, ta-da, 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 this can go. Where do we build our cave? Where's our origin? Right here. Let's drop that down a bit. So we're building our building blocks. Is origin? Yeah, no. It appeared to be on the correct spot. So there we go. I did nothing. 24 is correct for the example. Let's make sure that it works for our input as well. Oof, that was a bit heavier. I think part 2 might become interesting from a performance perspective. We're doing a little competition at work as well, so I'm gonna do a quick peek, see who has finished today's puzzle. Ooh, there's already 2 other colleagues. Kudos Thibaut and Jeroen for already grabbing your stars. Let's take a look at part 2. And I'm going to definitely save my part 1 so I don't screw anything up too big. And because version control is over, no, that's not true. Let's take a look at part 2. We realize we misread the scan. There isn't an endless void at the bottom of the scan. Oh no, there's floor. Oh, I love these puzzles. You don't have time to scan the floor, so assume the floor is an infinite horizontal line with a y coordinate equal to Okay, so there's an infinite floor at y plus 2 from the highest y coordinate of at any point. Yes. I understand the statement. In the example above, the highest y coordinate is whatever, 9, so the floor is at 11, makes sense. And it's infinite. And it's as if this line was in there. Yes. To find somewhere safe to stand. Oh my god, this is amazing. We're building sand pyramids and we're looking for safe pockets. We'll need to simulate falling sand until a unit of sand becomes to rest at the top. This is very Indiana Jones-like. Okay. In the example above, the situation finally looks like this after 93. That's like a quadruple of complexity. I really hope that I don't have to rewrite my entire algorithm for part 2 or rethink my data structures. How many units of sand come to rest using this new revelation? So, what's new? Floor. Floor is new. Floor is infinite. Floor is at y plus 2. So there's always something on y. That's the difference, right? There's always something on y. So this thing always has something. And where? It always has something on the floor. I think if we change that... Yeah, if we change that, everything should work out automatically. And we're going to do a bit of extra calculations that are not strictly necessary, because we know once we hit the floor it's done and we don't have to try left and right. But yeah, that's not going to be a problem for a... I don't know how big our problem space is, but I don't think it's going to be a problem. So let's have this always return something on the floor. So we just need to append one thing. And what is the thing? Thing with this x coordinate, but the y coordinate we don't really know yet. So let's figure out the floor. Let's figure out the y coordinate for the floor. So where is our floor? So these are all the coordinates. Can we grab the floor out of this? Yes, but we can grab the floor out of the cave. No problem. So these are all the keys, and then we just do... Nine is our highest y coordinate. That is correct. And we take the y coordinate and we plus 2 it. And that's where our floor ends up, right? And we do 2 plus this thing. I don't know why I do 2 plus. It's Yoda. I watched a lot of Star Wars. So yeah, there we go. That's the floor. If we provide our floor to our drop sand thing. Yeah, I'm just gonna pipe in the extra argument here and here. Does not make sense to have the floor come before the cave. So I'm just gonna move arguments around a bit. There we go. And it is floor is here. And drop sand also needs to know where the floor is, because that's the easiest way. So everything should compile once we do all our recursive calls. And now we know that on y, now we know that something is on the floor, so that is start x. Yeah, and the y coordinate is the floor. And that's also rock. We don't need to distinguish floor from any other kind of a any other kind of a material here. Floor is just a rock. In theory, I think we're done. There might be a small risk of burning up our CPU cycles, given how we modeled everything, or how we our types, our data structures. But I'm willing to take a look at where this brings us. Oh no, it brings us to infinite loop territory. There's a new halting condition. Once we have sand at rest at 5 at the origin, we can stop. So our fixed point is not really where we have to go. We have to go at until full. Let's call it until full. So it's not fixed point. It's if cave if there is a thing at origin. If we have sand at rest at origin, because that's probably the only thing that can end up there, we stop and otherwise we go. I think that's maybe. That's maybe. Yes, that is maybe. No, it's an option. I'm sorry. We're 1 hour in. My brain is mush. No, still infinitely looping. That's a shame. Let's start printing out iterations again to make sure whether or not it's a performance thing or a bug thing. Why is it halting at 25? It's that sounds like we have a floor bug, right? It's doing everything it did before, and at 25 we're supposed to fall on the floor, and now it's infinitely infinitely recursing somewhere. So I'm guessing we're infinitely dropping sand, and the sand has some problems finding the floor. Let's make sure that is what is happening. So, back to print event-driven development. This is our thingy. Let's take a look at what is happening in the thingy. What is happening in the thingy? Where are we at? Whoop, whoop, whoop. Are we not printing out iterations? Oh no, we're in infinite loop. I forgot. So that's 15, 15, 16, whatever, it's 24, 25, right? 22, 24, so we're almost at the... Probably this is where we start infinitely looping. What is happening here? This is a call, this is a call. Yeah, so why are we not hitting shit? Or why are we not hitting a floor, sorry. We have our cave, and there is some sand in it. 24 grains of sand to be precise. We find something on Y, and we say, hey, have you seen this? There's a thing at 502. 502. What does 502 mean again? There's a thing right here. Yes, there is a thing right here. So that's correct. So now sand should start a dropping, but it should a drop on wherever. It's not given us the place where it's going to hit, but it should be somewhere here, right? So we're expecting it to be y equals 10. So there should be something on y equals 11. That's what I'm hoping to see. So yes, there is something at 502. And there is something at 4993. Yeah, that looks... It's dropping. It's going down the pyramid. It should go until 9. So this is the last rock we meet. Oh, sorry. That was 24. This is 25. Hey, there you are. Oh no. Is it okay that that the floor is the first thing here? Are we somehow, somewhere? Do we depend on the order of things on Y? No, we don't. This will never be the case, so this... is this a problem? The cave is never empty again, so we're going to try... Cave is never empty, right? Oh, sorry, on Y is never empty. Because we always add some floor. To be triple sure, let's actually get rid of that if. So the cave is... If it's empty, or if on Y is empty, we have our bug again, our head will crash. Oh, is free. Oh dear. We have on Y, but we also have this is free thing. There is always something on the floor. That is true, but our code is not representing that fact. So let's plug in the floor. That's not the cleanest of designs to tackle this, but we're so close I can taste it, so that's how we're gonna do it. That is floor. So if location Y equals floor, so second location equals floor. If that is true, we are hitting the floor, so it is definitely not true. Free. I don't know why I'm doing this inside the pattern match. I'm confusing myself even as I'm writing it, so that was not the smartest of ideas. But okay, there we go. Yeah, let's give it one more run. I have the feeling that I'm flailing around, and I know the antidote, which is take smaller steps and test your stuff, but ooh, it reached an ending. $93, and it was very slow, but maybe it was slow due to the print statement. So let me just roll those back if I can, if my fingers become unfrozen. It's pretty chilly here. I think this week is the first week where we're hitting minus Celsius here in Belgium, and you better believe my fingers are feeling it. Okay, so we have 93. Is that what we are expecting? It is exactly what we're expecting. So I'm going to do a quick Hail Mary that what we built is good enough for our input performance-wise. So we've rebuilt the cave. We have a new floor, which is at 170. Until full, or fixed point has become a until full point calculation. And we're off to the races. And it takes very long. Let's print out what we're doing iteration-wise. we're hitting the 1 hour mark here. We're hitting the 1 hour mark. So this might be, if this does not end in a reasonable amount of time, this might be the point where I throw in the towel this morning and where I take another look at it after my work day. So here we go. Final shot. Why is it happening? Because our floor is infinite and sand can just keep rolling off the pyramid. It kind of makes sense. How would one speed this up? Where are we losing the most time? Where are we losing the most time? Lookups, probably. Lookups are a problem. Sorting stuff, filtering stuff. Not sure. I'm gonna let this marinate a bit. I'm gonna have a think on it in the back of my mind for the rest of the day. So yeah, we grabbed one of our star fruits. We did not grab both of them. I am very eager to return to this problem once I have the time. I am also very eager to return to the previous problems. To talk about parsec and parsing combinator libraries, stuff like that. But that will be for another time. That's all I have for today. Really fun puzzle. Yeah, that's all I got. So I hope to see you again next time on Advent of Code in F#. Bye-bye.